Today we're going to continue thinking about the two-column proofs, but we're going to take things a step farther today and do another step at the end that will be called CPCTC, and we'll talk about what those letters stand for here in just a moment. So when we were talking about our two-column proofs, we were able to show why triangles were congruent, and we would end up in that final statement with a triangle congruence statement on the left, and on the right we had one of our postulates saying why that was true. And we have talked about previously that this triangle congruence statement, it's really important the order that those letters are in because they have to correspond with the other congruent angles. So we would know that angle A, the first letter, and angle D, the first letter from the second triangle, those two are congruent to each other because they're each listed first. That makes them what we call corresponding angles. Corresponding meaning they're in the same location or they're paired together. And then B being second and E being second would be another pair of corresponding angles. And F and C, both being last, would be yet another pair of corresponding angles. So we have three pairs of corresponding congruent angles. And then the same thing is true for the sides. So one side of triangle ABC would be side AB. It's the first two letters. And that's going to correspond with the first two letters from the second triangle being DE. So the length of AB would be the same or congruent as the length of DE because they are in corresponding sections or order of the triangle statement. So those two would be corresponding sides. Then another side would be the middle and the last letter, so BC and EF. Those two would be a pair of corresponding congruent sides. And then you do the first letter and the last letter, so AC and DF would be the other pair of corresponding congruent sides. So when I look at triangle MLN as congruent to triangle RST, which angles are congruent is my first question. So M and R would be congruent. They're both listed first. L and S would be congruent. They're both listed second. And N and T, the last ones, would also be congruent. How about the sides? Which sides are congruent? Well, if you take the first two letters, ML and then RS, those two sides, then let's take the second and third, so LN and ST would be congruent. And then we'll do the first and last. So MN would be congruent to RT. How do you know they're congruent? Well, we know they are because they're listed in corresponding order. So they are corresponding parts of triangles that we know are congruent. So that leads us to say corresponding parts of congruent triangles are congruent. So it doesn't matter whether it's an angle or a side, it's just a corresponding part of congruent triangles, and that's really important, are congruent. This is better known as the abbreviation CPCTC. Corresponding parts of congruent triangles are congruent. Now, CPCTC will be used in proofs to show specific parts of the triangle are congruent to another specific part. But you must prove the triangles are congruent first. CPCTC will only be listed as a reason after you have listed a triangle congruence postulate. So I didn't give like background or questions to these, but here's what it should look like. You should have a triangle congruence with its postulate, then some piece by CPCTC. You would never list the piece and CPCTC first and then a triangle congruence. It has to be triangle congruence first and then CPCTC. Every time it has to be in that order. Now here's an example of a fully worked out proof. So we are given that PQ is congruent to RQ. So let's just take a look at that. Side PQ is congruent to side RQ. These two that are already marked, that's a given. So there's our reason. And we are told that angle PQS is congruent to angle RQS. So P to Q to S, that makes that angle that has the marking. And R to Q to S makes that angle with the marking. And that's our given. So we know these two things were given to us. What else do we know? Well, we know that QS is a shared side. So QS will be congruent to QS by the reflexive property. Remember, that tells us sides are congruent to themselves. That is enough, once we would mark that as congruent to itself with two little tick marks there, to now have side, angle, side, side, angle, side. So we can say the triangles are congruent by side, angle, side postulate. Last lesson, that's where we stopped. But now we want to prove instead that angle P is congruent to angle R. Remember, what your prove statement is should be the very last statement. They should match. Why are angle P and angle R congruent? Well, here's P and here's R. They are corresponding parts. And if you look at them here, it's second letter, second letter. And so therefore, they are corresponding parts of congruent triangles, which makes them congruent. CPCTC. Here we have another one. This one doesn't have any markings on it. So we're just going to go up here and use our statements. TV, right here, TV is congruent to WV, right here. And that's a given, so we would maybe put little tick marks on there. Then we are also told that TV bisects UX. So we would just write that, TV bisects UX, given. Now, by the way, when I name these technically should have a line segment over the top of them, but I can't get that to show up in my Chromebook. If I was on a Word document, I would, but I haven't figured out how to do that on here, and I don't have math script, so I'm just doing the best I can with my Chromebook. But segment TV bisects segment UX. So TV bisects UX all the way down to there. What does bisect mean? Well, bi means two. Sect would be like intersect. So it intersects, which would be right here at the point V, this line in half. So that means UV and VX are going to be exactly the same length. Well, if they're the same length, then we say they're congruent. So UV is congruent to VX, and that's by the definition of bisect. Remember, you can put definitions into, if they tell you a word up here, you're probably going to use the definition of it in one of your reasons in your proof. The only other thing we know, so now we'd have a tick mark here, and maybe two ticks there, a tick mark here, and two tick marks there. Then we also have this pair of vertical angles here at V. But again, because there's multiple angles here, we need to name them with three letters. V has to be in the middle. So UVT would be congruent to XVW, and that's because vertical angles are congruent. That's a theorem. And that tells us then that these triangles are congruent by side, angle, side, side, angle, side. So we would say triangle TVU, and remember to do that, you could do that one in whatever order you want. The next one has to match it. So angle T corresponds over here with angle W. So WVX, WVX, and by the side angle side postulate. Now what we want to prove is that TU, this distance here, is congruent to WX, this distance down here. So we're going to write exactly what our proof statement was in our last statement. And that will be true because corresponding parts of congruent triangles are congruent. TU are first and last, and WX are first and last. So they are corresponding parts of congruent triangles, so therefore they are congruent. Remember, you have to have the triangle congruent before you can use corresponding parts of congruent triangles. You can't just say corresponding parts are congruent. It has to be corresponding parts of congruent triangles that are congruent. So we have another example. We have AB congruent to CB. So AB, CB. And that's just given. And we have AD is congruent to CD, also given. So you might have 1 tick mark, 2 tick marks, 1 tick mark, 2 tick marks. Then we know that BD would be congruent to itself. So BD is congruent to BD by the reflexive property. Now all the sides would be marked at that point. So we know these two triangles are congruent by side, side, side. And yeah, I did it again. I copied and pasted and didn't change my letters. So let's make sure we change those to the right order. I'm going to do A, D, C. And in our triangle way over here, oops, we want to use, if I did A first, that means I would need to do C first. So C, and then I did D, and then B. Man, I'm making all kinds of mistakes. That should also be a B. Hopefully you caught that for me on the first time. So those triangles are going to be congruent by side, side, side postulate. Now the question is, why is angle A congruent to angle C? That's the prove statement. That goes as our last statement in our proof. And that would happen because they are corresponding parts where the short side and the long side come together, where the short side and the long side come together. So A and C are corresponding parts of congruent triangles, so therefore they are congruent. CPCTC. Take just a moment, see if you can fill in the blanks on this proof. I'll give you just a moment or two to look at it. All right, hopefully you thought through your steps. AC is congruent to CE, should be written right here at number 1, and your reason should be given. At number 2, we should have DC is congruent to BC as a statement. A reason is given. Why is angle ACB congruent to DCE? So let's look at that. ACB, that'd be this angle here, and D to C to E, so this angle here. Well, those are vertical angles. So number 3 should be vertical angles are congruent. Why are the triangles congruent? Side, angle, side, side, angle, side. So number 4, side, angle, side postulate. And why is angle B congruent to angle D? And that would be CPCTC. Corresponding parts of congruent triangles are congruent. Remember, always, 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 you must prove the triangles are congruent before you can use CPCTC. I should never see CPCTC written as a reason without, in a previous step, seeing that the triangles were congruent by one of the congruence postulates. Good luck as you work through your questions today. The assignment will look very similar to yesterday in that you'll have some to finish filling in and a couple to make on your own. And once again, don't hesitate to contact me if you have any questions at all.